analysis. And here is your Chapter 3, Lesson 5 notes video. We're going to solve rational equations, which does mean fractions in equations. I am so sorry. But we're just going to use the LCD to clear it out. So don't worry. Don't worry. We got this. All right? Now, first thing we're going to do, we're going to just identify LCDs. Okay, so I know this looks like a lot of questions, right? We're just going to look at some LCDs in these questions. That's it. All right, so let's start. Look at your denominators to find the LCD, or the least common denominator. So what can all these denominators multiply to become? That's what we're looking at here, okay? So look at A, right? Let me zoom in. There we go. Nice and zoomed. Okay. 4, 8, 2. What can they all multiply to become? 4 times 2 is 8. 8 times 1 is 8. 2 times 4 is 8. What's my LCD? What can they all multiply to become? 8. Okay, only look at denominators to find the LCD. All right, look over here, right? So x squared and x, those are my only two denominators. If there's a variable in a denominator, it has to be in the LCD. So what's the highest exponent of the present variable? X squared. So what's the LCD? X squared. That's how you think about these. I like to kind of factor my denominators and look at the pieces, and that's how I help myself pick the LCD. Okay, what are the factors present? And all those present factors, those all form the LCD, the least common denominator. Okay, like look over here. Think about this as x and 2 times x, right? So what would I have to do over here to get it to match here? You'd multiply by 2. So what's the LCD? It's 2x. Okay, sorry, I'm on D. And I wrote when I wasn't on the screen. Think about down here. Okay, look at those denominators, right? 2 and 4 times x and 2 times x. So the LCD definitely has to have a times x in it, right? But what can 2 multiply to become? 2 times 2 is 4. We've already got a 4 and an x. That is your LCD. So sometimes a present denominator is your LCD, okay? Other times, you've got to force it, like an h. Look at h. You got an x squared and a 2 times x and a 2 times x. But what's the highest present exponent? An x squared, right? And then we've got this number 2 that we have to multiply by. So the LCD is 2x squared. So remember, we have to multiply to become this denominator. Now, here's where I'm talking about factoring, right? So this is fully factored, this is fully factored, but there's a GCF here. So what do these have in common? They have an x, so I pull that out and I divide each term by x. X squared divided by x is x. Negative 3x divided by x is negative 3 or minus 3. Now look at each of those terms. What would I have to multiply these by so it would be exactly the same as this? An x minus 3. When I've got pieces like this, I literally just write them like this as my LCD. Okay, so when I've got pieces like that, that's what I write as my LCD. Same over here with I and K. All right, so I'm going to do those ones again. Look at I. You've got this is a piece. This is a piece. Wait, those are the same piece, right? So I could say for I that my LCD is x plus 3. That's one of the factors. And the other factor is this x minus 2. And again, this is just identifying least common denominators. Don't panic about this. We're going to use these and cross some of them out. So they're used to then get rid of pieces of the denominator. So don't panic when you're seeing these things, okay? Now, down here, okay, let's factor this trinomial into 2 binomials. And what does it happen to factor to become? Well, let's see. What are the factors of 25 that add to give me a negative 10? So x minus 5 and x minus 5 are the 2 factors of this. Well, what do the other denominators happen to be? They happen to be x minus 5. So what's the LCD on k? It's x minus 5 times x minus 5. Notice I'm not refoiling that. I'm leaving it as separate factors because that way I can easily cancel with denominators that I see. Okay? That's what we're starting by doing. Notice I only did a few of them, but I'm just identifying least common denominators. That's the first step. We're going to do these in 2 days. So we're going to spend 2 days on these. And we're going to kind of start with more algebra 1 style ones, which is like A and B and D, and even C is algebra 1 ish. F is algebra 1. It starts to become more algebra 2 down here. Okay, when you've got these much bigger denominators that you're dealing with. Okay, well, that's the first piece, is just making your LCDs. Okay, the second piece is once you have found LCDs, now we need to list any values for x that make the fraction undefined. So if you've got a variable in a denominator, you have to identify what that variable is not allowed to be, because you can't have 0 in a denominator. Now, it's nice and simple. If there's a single x or an x squared in a denominator, it's 0. So see how there's a single x here? X can't be 0 then. See how there's a single x here? X can't be 0 then. And by the way, what's 0 times 2? Still 0. X still can't be 0. Okay, so if that's the case, or like this is the case, that's still just an x is not allowed to be 0. Okay? If you have pieces like these, where they're separated by plus and minus signs, what you do is you plug in a value for x that when added to 3 comes out to be 0. And what would that be? Well, it's negative 3. So in this case, x can't be negative 3 because that would make this one 0. But what about here? What would we plug in for x here that you subtract 2 from it and you get 0? That would be positive 2. So in this case, x is not allowed to be negative 3 and it's not allowed to be positive 2. And you can just write it like this. Okay, you don't have to write a whole new x is not equal to, right? Now down here, remember that we factored this guy on the other page, and so it was really x minus 5 times x minus 5, right? And think about it. 5 minus 5 is 0, so x cannot be equal to, x cannot be equal to 5. I wanted to say 0 again, but that's just not true. It's 5. That's how you look at these, right? Up here. Remember, your LCD was over here, x times x minus 3, right? That was your LCD. Well, if you put a 0 in here, then you'd get 0 in a denominator, so x can't be 0. And if you put a 3 in here, then you get a 0 in a denominator, so x can't be 0 or 3. That's how you do these, okay? Look at the LCD and what is the LCD not allowed to be. That's how you would figure out what you are not allowed to be in these fractions. So if you have a variable in a denominator, you have to consider what values x is not allowed to be. That's putting all the pieces together for solving, okay? So now we're going to do the actual solving part. So notice I kind of started you out. Let's just find the LCD. The second piece is let's just find what x isn't allowed to be. The third piece is putting those together and solving equations. Again, 2 days to do these. No panics. We got this. We got this. You did this in Algebra 1. We're just taking it to the next level, and it's actually not that bad. Okay? I'm going to do a bunch. All right? I'm going to do a bunch. I'm going to start with a nice, easy Algebra 1 style. So A is a nice, easy Algebra 1 style. First of all, what's my only denominator? It's x. So the LCD is x. What is x not allowed to be because it's in a denominator? Well, it's alone in a denominator, so it can't be 0. And now you take the LCD and you rewrite every piece of the equation being multiplied by the LCD. There we go. Every piece is being multiplied by the LCD. So 26 over x and then times x here. Now the beauty of this is most of the time the LCD cancels with a denominator, and just your numerator is what comes down to the next line. When it can't cancel like this, you just bring that down to the next line. When it can cancel, bring it down to the next line. Okay. Now we just subtract 2 from both sides. You're left with negative 3x equals 24. Divide both sides by negative 3. Negative 3, there we go. You get x equals negative 8. Now, just double check. What was x not allowed to be? It was not allowed to be 0. My bad. It was not allowed to be 0. So, since your answer was not 0, you're good. Okay, that works. Let's do another one. Algebra 1 style, of course. We'll stick to Algebra 1 style for a couple. B, here's a good one. Look at all those denominators. So a 5, a 3, a 15, they can all multiply to become 15. So your LCD is 15. Do I have to write an x cannot be equal to? Nope. Not in a denominator. I don't have to worry about it. So now I just take 15 and multiply it by every piece of the equation. Do this rewrite because I'm telling you right now, it's different in each section if you cancel out a denominator. And so because of that, you want to make sure that you have the right leftover to be multiplied by your numerator in each of these pieces. So like here, 15 divided by 5 is 3, and 3 times 2x is 6x. 15 divided by 3 is 5. 5 times 1 is 5. 15 cancels to a 1, so this whole x, 7x, minus 2 comes down to this line. And now it's just a simple equation to get all the x's on one side and all the numbers on the other, okay? So minus 6x from 7x here, and add 2 over here, and you get 7 equals x. And again, I can keep that because there wasn't a value x could not be equal to, because there was no variable in denominators here. So we only have to worry about what x can't be if there's a variable in the denominator. All right. D. D is still Algebra 1 style, but, you know, after you did all the quadratic stuff. So look at your denominators. X squared and x, right? Nothing over here, denominator-wise. So your LCD is the highest present exponent. That's x squared. Notice x is alone, right? So x cannot be equal to 0. So we are going to have to watch out for that this time. So now what you do is you take this LCD and you multiply it by every piece of the equation. Okay, and notice in places like right here, it's going to cancel completely, so don't worry too much. All right, it looks like it's super intimidating, but for the most part, it cancels. And so you really don't have to worry quite as much as you think. Here, I'll put all these pieces in parentheses. You don't have to worry quite as much as you think. There's going to be cancellations. Like here, the x squareds completely cancel and you're left with a 10. Now here, the x squared cancels and this x is gone, but this is left with an x and it's a negative. So it's negative x times 3 is negative 3x, right? Okay, and then on the other side, nothing canceled. So 1 times x squared is just x squared. 1x squared is x squared. Well, I got an x squared. This is solving a quadratic. It's a quick one. It's a factorable one. But we still have to get everything to the x squared side because you keep x squared positive. This is kind of review, right? You keep x squared positive, so move these guys over by their opposites. And notice I'm putting them in descending exponential order, so like the order of a polynomial. X squared plus 3x minus 10. And you have to factor this into 2 pieces. So you think, what are the factors of 10 that subtract to give me a positive 3 in the middle? So that would be, how about 5 and 2? Positive 5, negative 2, because we got to get a positive 3 in the middle. And then T-chart. You remember that, where you set each factor equal to 0. And you get x equals negative 5 over here. And over here, you set this factor equal to 0, and you get x equals positive 2. And I get to keep both of these answers. Okay, I'm going to check both of these answers because what was x not allowed to be? 0. I'm good. I just didn't want to completely disrupt the next problem, so I'm good. So yeah, you do have to make sure you can factor a quadratic, okay, and solve, right, the T-chart. Once you get out of geometry, once you get out of algebra 1, we assume you can do at least this, solving a quadratic equation. I know I threw it in a little bit already, but now I'll start throwing it in more and we'll review it more. But still, you know, we have more review on it, but still you want to make sure you know how to do that. All right, keep going. Let's stop with F. I think that'll be enough for today. Let me just look. Oh yeah, we'll do more. We'll do more later. There's a lot more, right? I'll do more tomorrow. We'll stop with F. We'll stop with F for today. Okay, actually we already saw F as far as LCD went, right? So just look at denominators. You got a 2, you got a 4x, you got a 2x. Well, we know that x has to be part of the LCD. We know we're going to have to state something x can't be. What can 2 and 4 both multiply to become? They can both multiply to become 4, right? So 4 and x multiplied together is what my LCD is. So 4x, which it is one of your denominators, so that's good. Then, of course, we have to state x it cannot be equal to 0. You've got single x's here. That's when it's x can't be equal to 0. If this was actually x minus 2, that's when x couldn't be 2. Okay, so think about it that way. Well, now I take my LCD and I multiply it by every single piece of the equation. So 4x times the 1/2 here. And 4x times this whole thing. So x squared minus 7x plus 10 divided by 4x. This isn't a bad thing. Trust me, it's going to cancel, so don't panic, right? And then minus this 4x times 1 over 2x. Okay, and so there's still canceling happening there. So don't panic about these things. That's canceling that happens. You get rid of that fractional thing, right? Get rid of that fraction. So like here, the x is going to have to stay, but what's 4 divided by 2? Well, it's 2. So you're left with 2x times 1, which is just 2x. And that's one side of your equal sign. And then look over here. This whole 4x canceled with this whole 4x. Just bring this stuff down to the next line. And over here, the x's completely cancel with each other. 4 divided by 2 is still 2. You just have to watch that it's the negative out here. So negative 2 times 1 is negative 2. Okay? So now what I'm going to do in the same step is I'm going to get my x squared. All my stuff is with it. So when I see a positive x squared involved here, I need everything from the whole equation to go over to the x squared. So this guy I'm going to subtract over, and I'm going to line him up with the negative 7x already here. And then these two that are already on the same side are like terms. So you get a 0 over here. Bring down your x squared. It's fine. Nothing added or subtracted with it. This ends up being a minus 9x. I was writing it correctly. I wasn't saying it correctly. A minus 9x. And then here, 10 minus 2, because they're on the same side of the equal sign, is a positive 8. Now that's a factorable. That's a factorable trinomial. It factors to become, let's see, what are the factors of 8 that will add to give me negative 9? So 4 plus 2 is 6, so it's not going to be those. So 8 plus 1, 8 times 1 is 8. 8 plus 1 is 9. X minus 8 and x minus 1. Remember that now that I'm saying it? I'll keep saying it, don't worry. I'll keep walking you through factoring. It's one of my faves. I mean, how can you not go wrong with factoring, right? Right? Factoring's so much fun. There we go. Can I keep those? X isn't allowed to be 8. Cool. X isn't allowed to be 0. I've got x equals 8, so that's good. And x isn't allowed to be 0, and I've got x equals 1. Cool. Done. There we go. That should be enough to get you started on the first day's homework. I'm going to do a second video with more examples, right? So these more examples will come back to these notes And these examples, because these are Algebra 2 style examples, okay, so we'll come back to these ones for the next video. Do two separate, okay? 2 separate days, 2 separate videos, spacing it out since you yelled at me for too many videos this week. All right. Good luck, guys. Ask me for help in class. Come to office hours after school if you need help with these, okay? I shall help you. I promise. Good luck. I'll be seeing you.